All right, so today we're going to be looking at conditional probability, and the one thing we need to discuss is what exactly is conditional probability. Conditional probability is the likelihood of an event occurring, given that another event has already occurred. So it's like saying, I do this after this has already happened. So the way to write a conditional probability is you're going to use P. So say if the probability of event A given that B has already occurred. So the probability of event A given B has already occurred. So this is a conditional probability because you have to focus basically on whatever this is to begin with to find the probability of that one. And I do have an example we're going to look at. So it says 100 migraine headache sufferers participated in a study of a new medicine. Some were given the medicine and some were not. After a week of participating, they asked if they experienced headaches. So it says, what is the probability that a participant who took the medicine is not getting headaches or did not get a headache? So for this one, we're already just looking at participants who took the medicine. So we're only going to look at participants who took the medicine. So we're only looking at those who took the medicine. So if we look at our table, took medicine is right here. We're looking at all of these people. But only this column. We're only looking at this column. Now that we're only looking at this column right here, we want to find the probability that the participant who took the medicine did not get a headache. So only looking at this column, let's see who did not get headaches. So it says no headaches right here. 54 people. No headaches. Out of our total who took the medicine, 65 total. So to find the probability of event A given B, we're going to find the number for B and the number for A union B. This is how we find it. I should have put probability. That's fine. Okay, so looking at this one, we're going to start here. We know that 54 people who took the medicine did not have headaches, and 65 people took the medicine. This is our ratio. This is our conditional probability. And it's going to be roughly, if I were to type that into my handy dandy calculator, if we do 54 divided by 65 and multiply it by 100, it'll give us our percent, and it's about 83%. So about 83% of people who took the medicine did not experience headaches. So again, this is conditional because it says that they already took the medicine. That's the only group we're going to look at. If it said they took no medicine, we'd look at this column instead of that one. So we have to focus on it in just terms of that one specific region. So it says because they took the medicine, we're only looking at those who took the medicine. Let's do another example for this one. And we're going to look at a standard deck of cards, and there's only going to be about two that we're going to look at for these. So a standard deck of cards, I already wrote out some information for you. It says find the probability that a red card is randomly drawn from the deck is a jack. That a random card that is red. So first off, we know that the card's already red. We want to find the probability of it being a jack. So looking at this first one, so let's do the probability of jack given that it is a red card. 52 cards are in a deck. Half of those are red. So that means 26 are red. Why? Because 26 is half of 52. There are 4 of every face card and every number. A jack is a face card, so that means there's going to be 4 jacks in the deck. Half of which are going to be red because half of the deck is red. So that means half of 4 is red, or 2 red jacks. So we know that we already drew a red card. So our N of R is going to be 26. And our number for jacks in union with the red cards, well, we know there's 2 red jacks. So to find the probability, we're going to take our number for the union of R and set it over the number for our red cards, or 2 over 26. So again, we take the 2 jacks, set it over 26 because we already know we drew a red card. 2 over 26 simplifies to 1 over 13. That is our probability. Let's do a different one. Let's try another one. Let's find the probability that a jack randomly drawn from the deck is red. So this time we're going to look at it. We already know we drew a jack. Well, we know that there's 4 jacks and 2 blackjacks and 2 red jacks. Well, we want to find the probability that that jack that we already drew is red. So again, we're going to set it up. The probability of a red jack is going to be the total number of red jacks, which we know is 2, over the total number of jacks because we know we already drew a jack. So it's going to be 2 over 4 or 1/2 probability. And let's do one more using a standard deck of cards. Let's find the probability that a spade drawn from the deck is a face card. Aces are not face cards. So let's talk about the probability that a spade drawn from the deck is a face card. Now I want to discuss what face cards are. Face cards are jacks, queens, and kings. And again, there's 4 of each of these in a total deck, 1 of every suit. A spade is 1 suit. There are 4 suits in a deck. So there are 13 spades in a deck. And these spades have a jack, a queen, and a king. So there's 3 face cards for spades. To set up this probability of a face spade, we're going to take our total number of spades and put the total number of face cards over top of it. So there's 3 out of 13. Because we already knew we drew a spade, so that is our total. And we know there's 3 face cards in the spades. So we set up as 3 over 13. All right, guys, I want you to do textbook page 949. You're going to do 1 through 14. If you have any questions, message me on Schoology. I will be giving the SAT, so we will not have any Teams meetings. No Teams meetings that day, all right?